Hey everyone, I'm Dan Petro from Bishop Fox, a lead researcher and longtime pen tester, and today I'm going to talk to you about Eyeballer. It's an AI-based pen testing tool that I wrote that can help make a better sense of a large external network footprint. But first, before we get started on that, let's talk about the problem that Eyeballer is trying to solve. I think that's a good way to understand what the tool does and kind of how it works. So the basic problem is around the external network penetration test. We do lots of kinds of pen tests at Bishop Fox, all things from application penetration testing, where we look at a particular application, a product security review, where we're looking at like a piece of hardware often and taking it apart, desoldering chips. And one type of pen test that we perform is an external network penetration test. So this is where we try to hack into an organization from the outside, like from the external perimeter, hence the name. So the very first thing we want to do in this sort of process is get a sense of what the external perimeter of the organization is. And so this will involve doing things like nmapping the external IP space, getting a sense of what ports are open, what IP addresses are available, what servers are available from the outside, right? And so one segment of this penetration testing activity involves web-based ports, so 80, 443, that sort of thing, that have a website open or a web service. And very often these external network penetration tests are very, very large. So it's not just one server that's available, not just a dozen servers, but in fact, thousands or tens or even hundreds of thousands of IPs that are potentially available on the target network. So in order to effectively penetration test these servers, we have to get a sense of what all is on there, like what kind of servers are available. And so there's plenty of tools that are already made that will go and take screenshots of these websites for you. They use a headless Chrome to go in one by one, take screenshots of all of these servers. There's tools like Eyewitness or GoWitness, Electric Scan from one of our own developers, Joe DeMazy here at Bishop Fox, that can do these sorts of screenshots for you. And so at the end, what you're left with is this mountain of screenshots of websites that are in scope for the target. And you're sort of left with this game of like trying to find the interesting bits from this mountain of noise. So you're trying to find the needle in the proverbial haystack. And so what Eyeballer does is it looks at these screenshots for you and tries to pull out the interesting bits for you. It doesn't actually like hack into anything, if you see my meaning. It doesn't like actually perform penetration testing activities. It sends no packets out to the outside world. All it does is look at these screenshots of websites and try to tell you whether there's something interesting there that could potentially result in a vulnerability. So it's not looking for a specific vulnerability. It's not a vulnerability scanner. It's just looking at the screenshots of the website like you do with your eyeballs and try to identify if there's anything that's worth following up on. So specifically, what is Eyeballer actually looking for? It's looking for 5 different things. One is old-looking sites. So an old-looking site is the sort of thing you recognize it when you see it, right? It's got blocky frames, broken CSS, a certain je ne sais quoi of a website that was made in the early 90s. Websites that are really old are not just ugly to look at, they're also typically filled with vulnerabilities, things that you can exploit, whether they're known vulnerabilities or potentially things that you could find yourself. So anytime you find something that looks really old, even just to the eye, that's just gold in terms of penetration testing. You want to hone in on those really quickly. So the ability to identify these old-looking web applications and zero in on them quickly is really, really valuable to penetration testers when there's tens of thousands of servers in scope. So the next are web applications. Web application, we're making a distinction here between like a splash screen. So lots of something you'll find on these large-scale external network penetration tests is that many of the websites, many of the IPs in scope are actually just bogus sites. Like they just have a blank white page, or it's like an Apache or IIS default page, basically something that's uninteresting. There's no real functionality there. as opposed to a web application that has, buttons to click on, forms to enter, functionality for you to perform. Things like functionality that you could potentially penetration test. This is good because it means that there's back-end functionality that you could latch onto and potentially exploit. So these web applications are definitely something you want to pull out and perform further inspection on. Now, of course, Eyeballer isn't going to do that penetration testing for you. All it's going to do is identify that there was a web application. So the next is a login page. Login pages you might think you could find automatically using some heuristics, but it's actually really tricky. In practice, websites are built dynamically in the DOM using JavaScript, and it's not as simple as just looking for a input field on a HTML site. That parsing the HTML is pretty much impossible, and it's impossible to try to go about it that way. But you know a login prompt when you see it, and so does the machine. Importantly, login prompts, when they're on a website, imply that there's further functionality that you currently don't have access to. Because, of course, if there's authentication, if there's a login prompt, that means there's something else that the login prompt is preventing you from accessing. This is valuable because it means that you're only looking at the tip of the iceberg, and you might try, brute forcing passwords as a follow-up to seeing a login prompt. Or maybe we already know some usernames and passwords, and so we can try to guess those known usernames and passwords against the login prompt. In any case, it's definitely valuable to identify where the logins are and follow up on those later. Next are actually two things that we might not be interested in that we want to filter out. Things that are probably uninteresting and that we want to remove from our big list of screenshots to not bother with later. So first is custom 404s. These little cutesy sayings that has like a picture of like a broken robot that says oops on it or something like that. Basically, it happens when a website is broken. These things are basically like impromptu CAPTCHAs. They are really hard to identify. They don't always have the words 404 in them, and very frequently the page itself doesn't return an HTTP code of 404. It actually returns an HTTP 200. That's just how websites are made these days. It's annoying. I don't know. These sites tend to indicate, these pages tend to indicate that there's nothing actually interesting here. Like there's no functionality to latch onto, unless you might be able to redirect to a home page or something like that. In any case, this definitely indicates that something went wrong and is not necessarily something we need to pen test. And so the Eyeballer will try to identify these and remove them from our list. And then lastly are parked domains. This happens when something used to be live but isn't anymore, or the domain is registered but is currently being parked by a domain registrar. It's these sorts of pages. And all that really means is that this is not really a website. It's just being captured and shown to you. It's typically just got a bunch of advertisements on it. These tend to plague domains that are no longer live and are actually not deserving to be in scope. We want to remove these from our list of things to attack. All right, so let's get into a demo before we get any further. So what you're looking at here is a redirection from eyeballer.bishopfox.com. This is basically just a GitHub IO page. This is the web interface for Eyeballer. So what I'm going to do here is I'm going to upload some files, though as the prompt says here, they're not actually uploaded anywhere. That basically this whole thing happens right here in browser. So I'm just going to get this going because it's going to take a minute to classify, and I'll talk while this is going. So what this is doing is it's going to classify these images into each of our 5 categories entirely in browser, just in JavaScript. So this, if you're familiar with GitHub IO pages, you know that there is no backend. It's literally just some HTML and JavaScript. So the whole point behind Eyeballer is that you're supposed to be able to use this on pen tests with sensitive information. And so that means that we can't be uploading data to a server that could potentially get hacked. And I don't want to have to keep up with a backend server anyway. So this whole site here is designed to work entirely just in the browser. So this classification that's going on right now is being done by Firefox right now just in JavaScript. So that's pretty cool. So the code is written both in Python, as we'll see a bit later, but also as JavaScript for this front end. So that way you can do this kind of forward classification. So what it's going to do, basically you just drag and drop some files. You can put as many as you want. We've tested this with like tens of thousands of files, and it works just fine. You just have to wait a little bit longer for the machine to actually classify it. And if you happen to have a good GPU, that tends to speed up classification quite a bit. So using this interface, anybody can use Eyeballer like really simply. There's no need to install a tool or fight with dependencies, and you can just sort of use it. In fact, if you're watching this at home, you can follow this along right now. In just a moment here, we'll be done with the classification, and we can look at the results. So here's each of our 5 categories. And what you can do is select each of these to always include or not include. So the defaults right here is that it'll show you the results that must be a web application and are not custom 404s or parks domains. So for instance, if we wanted to see all applications that fit this classification, there's 196 of them. We can hit the export button, and then it'll download to our local computer so that we can get a CSV file, a spreadsheet of those results. It's that simple, and then you can follow those results and pen test the results. You can also multi-select these things, so if you want to look at just the things that are web applications and are also old-looking, you can see there are 3 of those. So those are going to be very interesting to look at. Or if you wanted, you can see there's a 4th one here that is an old-looking site that is not a web application. This often involves things that are like appliance machines that maybe don't have a lot of functionality behind it, maybe like a router front end or something like that, will often be of this sort of category. And it's really that simple. That's all there is to it. If you want to go back to the beginning, just hit restart, and we're back to the start. So how does Eyeballer actually work? Before we get into any of the code, let's first talk about the data engineering problem, the data collection problem. Basically, for any convolutional neural network to work, these sort of classification problems like this is, you need to have a corpus of data. You need to, in order to tell the difference between cats and dogs, you need for the machine to have a huge picture library of cats and a huge library of dogs. And also it has to know which are which ahead of time. That way you can train the machine to say, these ones are cats, these ones are dogs. And then when you give it some new image that it's never seen before, it'll be able to apply what it's learned to that image. That's the basic idea. And rather than cats and dogs, we can just give it pictures of websites and the categories of those websites. The difficulty comes in the kind of chicken and egg problem we have here, right? In order to tell the difference between cats and dogs, you need to have just tons and tons of pictures of cats and dogs, varied images, some from behind, some from in front, some from above, different kinds of dogs. Just think of how many different kinds of dogs there are. There's a lot of variety of dog, right? If you'd like for your machine to know the difference between a cat and a dog, you've got to have thousands and thousands and thousands of pictures of each of these. And you also, importantly, can't use the computer to label these pictures for you. Because, of course, if you had a computer algorithm that could tell the difference between a cat and a dog, then you wouldn't need to make this neural network program to begin with, would you? Which basically means you have to have a human being go through laboriously, one by one, by hand, and label every single one of these. So that was quite a challenge in making Eyeballer, was in gathering the data and appropriately labeling them. It was basically just me and a couple of helpers just going through one by one screenshots of websites and labeling them individually. Is this a 404 page? Does this have a login? Is this a web application? What is this? And there's really no good way to shortcut that, because of course, if I had a way to shortcut it, then I wouldn't need Eyeballer to begin with. So the full list of images that we use, basically the training data for Eyeballer, is public. It's on our Kaggle page. It's linked to on our GitHub here. And it's all free and open source for you to look at. The images are not as many as we'd like. There's something on the order of like a couple small tens of thousands, which is by machine learning standards quite small. If you look at a larger corpuses of data like ImageNet, you're talking about like hundreds of thousands of images that have been farmed out to many hundreds of volunteers or paid employees. But we don't have those kinds of resources, so it was basically just me. That's a hard part about doing machine learning is getting this training data. Is often you wind up in this problem of data engineering that has nothing to do with the machine learning, that has everything to do with just making sure that your training data is good. One thing you'll find with machine learning programs is that garbage in, garbage out has never been so true. So the first thing that you need to know about machine learning programs is that this training data is extremely sensitive. If you start giving it bad data or incomplete data, then the results will wind up being completely poisoned. For example, if every login page just happened to be blue, we just didn't have enough training data, say, and just the vast majority of the login pages just happen to have a blue background, then the machine is going to very quickly learn that blue backgrounds mean login pages. It's going to learn the wrong thing. And the best way to avoid those kinds of problems is to have lots and lots of examples of websites that are varied, that are from different sorts of geographical regions, that are different languages, that are made in different frameworks, different programming languages, as big of a variety as you can make it. So it's a really hard problem, not one that can be easily solved. All right, well, this is developer land after all, so let's dig into the code a little bit. This is the Bishop Fox GitHub. We mentioned that eyeballer is completely open source, so it's just github.com/bishopfox/eyeballer. You can find all the code and the link to our training data from here. So most of this is pretty standard. We don't have time to go over everything inside of the source code, of course, but there's at least a few things that I wanted to point out here in terms of the source code. So obviously this is all in Python. It uses TensorFlow, which is like one of the most popular neural network libraries made by Google for making AI programs. Most of the source code, at least the interesting bits, here is inside of the model.py file inside of the eyeballer directory. And right off the bat here, what we're going to see is our neural network declarative statements from Keras. So if you're familiar with neural networks at all, you might know of Keras. It's this really great abstraction layer that helps build neural network programs. So eyeballer is very much like using existing tooling and is not necessarily a scientific breakthrough in the field of neural networks itself. We're basically using the same technology that we use to tell the difference between cats and dogs, only in the field of computer security. So but that's great. So the what you're seeing right here is us stacking up a sequential model using a couple of layers. So the first one here is a pre-trained layer. So again, since we're looking at images of data, the first challenge behind that is to how to feed that data into the computer meaningfully. And so that's where the convolutional neural networks come into play. This specifically here is a MobileNet layer, which if you're familiar with your neural networks, is actually one of the older models. There's some newer convolutional layers that are actually more advanced, like Inception v3 and things like that. I think there's even newer ones than that. And we tried a bunch of these, and curiously, MobileNet wound up working the best for us. I think, I'm not 100% sure why this is the case, but my best guess is that in terms of visual complexity, websites are actually not all that complicated. That the like usually when you're looking at images like this is the weights are immediately taken from ImageNet. ImageNet is like I said earlier, a library of pictures, things like basically photographs of things side on. So pictures of cars and planes and animals and pets and people. And there's a lot of visual complexity to that data set. And so many times in order to tell the difference between, say, like a cat and a person, you have to tell the minor textural differences, right? Like a cat has a very sort of different texture to it than a person does. And there's a lot of complexity involved in processing that information. Whereas a website is a lot more straightforward in terms of the visual complexity at the nitty-gritty level. And so MobileNet, just being small and lightweight, it's named because it was used for like mobile phones, basically. Something that is so lightweight you could run it on your phone. That the simplicity behind it is better suited towards like our challenge here, our task. So once we have that, and we can then feed this in through a couple of just connecting pieces into some dense layers. These are what are referred to as the hidden layers of the neural network, something that actually does like the high-level thinking about what is contained inside of the image, as opposed to just what is like at a very superficial layer on the image itself. So this goes through some dropout layers, which are really just there to prevent overfitting. That's there like as a way to add some noise during training so that we don't overtrain, overfit on our data. And then finally out into just one of our data labels. So importantly, our problem here of eyeballer is a multi-classification problem. It's a multi-label problem. So something can be both a login page and a web application, or it could be both like a custom 404 and a web application. There's any number of combinations that this data can be in. And so it's not simply like cat or dog. It can be cat and dog, if you see my meaning. And so that necessarily means that's going to inform some of the parameters down here into when you compile it. So like binary cross entropy has a loss metric would be really important. And also I'm using the sigmoid function here as opposed to like a standard ReLU or something like that going into the last layer. But that's all kind of technical. We don't have to worry about that stuff right now. Basically, at the highest level, what you need to understand what this is doing is the very first layer is going to look at the image as a whole. It's going to convolve on that, which is like a mathematical process, and drop it down into a smaller layer that's only 256 nodes wide, and then squeeze that down into something that's only just 128 nodes wide, and then squeeze that down into something that's just 5 nodes wide. And eventually at the end, we've got 5 bits of information, so 5 like data points that will tell us for each one of our data labels whether it is or is not one of those labels. All right, I want to show you one more really cool feature of eyeballer that we programmed in ourselves, and it's the ability to make a heat map of an image like this. So let me show you what this is doing here. Well, basically what we do is, this is a debugging technique in order to find out like what is going wrong with the program when it's not working very well. With a normal program, you can kind of step through the code, like as it's working, but that's not how neural networks work. If the program, for instance, looked at this and said, I think that this is not a login page, or got the classification of this wrong, right? We can look at this and clearly see this is a login page. I think we can agree, right? But what is the computer actually thinking? It's a little bit hard to divine that by just looking at the weights of the neural network's model. So one way of doing that is by making a heat map. So what we do is we classify the image by occluding a certain section of it. So we'll take this top left area right here, right? And we'll cover it up and then ask the machine, what do you think this is? And then we'll take another section, cover this section up right here, and then ask the machine, what do you think this is? And then just keep on going, basically slide it back and forth, this little box that kind of occludes the section, and keep on asking the computer what it thinks that the image is. And we can use that to get a sense of where it thinks that the login page is on the screenshot. So you can see what it looks like here. You can see that the machine really hones in right on this exact location as the spot where the login page is, which is good because it's getting this one correct. But in instances where it got it wrong, this is actually really useful to think that like, oh, it saw something up here in the corner that it falsely recognized as a login page. And that can be really useful in terms of when we're going through and gathering data and making the code to get a better sense of like, what does the machine actually think it sees when it looks at these websites. So this is a really cool feature, something that we had to make by hand. This isn't a default feature of like TensorFlow or anything like that. So I thought it was really cool. All right, well, that's about all that we have time for. If you thought this was cool, come and check us out at our website at bishopfox.com. Thanks a lot.